Hi guys, this is the video for chapter 10, lesson 3. So continuing with our topic on circles, I would recommend writing down some notes first before we do some of our practice problems on the study guide. So make sure you pull out your notebook and record some notes. So this is 10.3. What we're going to look at today are arcs, continuing with our arcs, which we talked about last class, and chords. So remember we talked about how a chord is a segment that is on a circle where the endpoints are on the circumference. So here's a circle, and let's say that I have two chords on my circle, and I'm going to name this chord F, G, and I'm going to name this circle like P or something, circle P. And this chord is H, J. So here's the deal. If you have chords that are congruent, what will end up happening is that your arcs that are created by the chords would also be congruent. So I'm going to say these two arcs are also congruent. And so a chord will always break a circle up into a minor arc and a major arc. But if we're looking at chords, they're corresponding and if they're congruent, then the arcs that are corresponding to those chords will also be congruent. So let's say that this is 60 degrees. This arc is 60 degrees. Well, this arc would also be 60 degrees. And that's just talking about this part, H to J and F to G. So FG equals 60 and HJ, arc HJ equals 60 degrees. Now, oppositely, if my arcs are congruent, then my chords will also be congruent. So if I saw this circle and the arc was given to me as being congruent, where I knew FG and HJ were congruent, those arcs were congruent, and this segment was 10 meters, then FG would be the same exact measurement. So you can relate these two truths to each other in that way. So let's take a look at our study guide. And we're going to take a look at our chords and our arcs. So number one, we have a arc here, two chords that are congruent. So that means these two arcs should also be congruent. And this little arc right here is 64. So if I were to find the total arc angle of a circle, I know it would be 360. So I could do 360 minus 64 and all that divided by 2. So you're going to kind of have to use some logic here of what you know to be true about angles of a circle and kind of use that to help you narrow things down. So plug this in, and each arc will be 148 degrees. X is 148 degrees. Okay, taking a look at number 2. Here's our chord again, and the chords are the same. The chords are congruent. Now, they're asking for a central angle, and we've been given this arc angle, 116. So if you were to guess, what would this arc angle be? Well, it would be the same, right? That would be 116. And last class, we learned that a central angle has the exact same angle measurement as the arc angle. So that means X would have to also be 116. And I didn't even have to do any math there. I just had to transfer my information and narrow it down. Okay. Next, I have two chords that are 4, and then I'm asked to find what x would be. Well, these two arcs should be the same, so x would hopefully be 82 degrees. Okay, looking at 4, it's very similar to number 2, so go ahead and see if you can figure out number 2 and solve for this AC, this arc AC, what that degree would be. Okay, so if you paused it and worked it out, hopefully you did 360 minus 90 and then divided that by 2. And so plugging that in, 360 minus 90 divided by 2 is 135. All right, now we're looking at the chords. We need to find x still. So these arcs are congruent, which means I know my chords should also be congruent. So because I know these two should be equal in measure, I can use an equal sign to set them up and then work this out algebraically. And divide by 2x, 2x equals 7. And if I plug this back in, 2 times 7, which is 14, 14 plus 4 is 18. So both of these should be 18. Okay, same idea here, right? I know that these two chords should be congruent. So 2x plus 1 is equal to 5x minus 5. Work it out. I'm going to add 5 to both sides so that I get positive numbers. And then I'm going to subtract 2x. So I have 6 equals 3x. And x, I believe, is 2. All right, pause and work out 7, 8, and 9. Number 8 and number 9, there's 2 circles drawn. However, if you know that these arcs are the same, then you know that these chords will also be the same. So you can kind of bring these two together as having some relationship. And you know that it tells you that these two circles are congruent. And so because of them being congruent, you can trust that if the arcs are the same, the chords will be the same. Okay, so hopefully you've worked it out, unpause, and now you're working, taking a look at your answers. This would be 3x equals x plus 2 minus x. Now I have 2x equals 2, x equals 1. Here I've got 6x equals 2x plus 24 minus 2x on both sides. 4x equals 24, divide by 2, x equals 6. Working this out, 9x minus 78 equals 3x. Subtract 9x on both sides. When I subtract, I get a negative 78 here and a negative 6x here. Divide by negative 6. And negative divided by negative becomes positive. X is 13. All right, let's continue with our notes. So continuing with our notes. All right, so here's a circle. And here is the center of my circle. And I'm going to just draw a diameter through my circle like that. So this cuts my circle into 2 equal parts. Now, something that's interesting is if a diameter and a chord intersect and they make 90 degrees. So I'm going to write this down. If a diameter slash a radius, honestly, so slash a radius, is perpendicular to a chord, then what happens is it bisects the chord and it bisects the arc. So remember the word bisect, that means split into 2 equal parts. So if I'm going to label this, what I see here is this diameter and this chord are 90 degrees, they're perpendicular. These 2 chords are now going to be congruent, And these two arcs are also congruent. So it bisects, it cuts it into two equal parts. And so if I were to label this like X, Y, Z, A, B, then XB is congruent to BZ, and arc XY is congruent to arc YZ. These two sides are congruent, these two arcs are congruent, and all this is true if AY is perpendicular to XZ. It's only true if these two segments are perpendicular. So let's go back to our study guide and take a look at some problems so we can let this sink in. So looking at our first picture here, we've got a radius. This time we just have a radius. So that's what I meant when I said a radius or a diameter, because sometimes when they draw the picture, they don't draw the full diameter, but you know that a radius and is just half of a diameter anyway. So if you wanted to imagine, you extend out the other part and that would be your diameter, right? So your radius and your chord now are congruent. So this says the radius is 3, which means like QP, this whole segment here is, sorry, not 3, it's 13. And then RS, this whole entire segment here is 24. Okay, so let's talk about what we need to find, and then I'll kind of guide you through this. So find each measure, round to the nearest hundredth. We need to find the measurement of RT. All right, so if I know RS is 24, then I know RT just is half of that because it's being bisected. So half of 24 is 12. So RT is 12. Nothing crazy, right? So RT is, where am I? Right here. RT is 12. Okay. Now they're saying, what is PT? All right, so this is a little bit trickier because I'm looking for like this little tiny segment. So let's talk about what we could do here. And I'm gonna bring you back to our notes. And if you wanna write this down in your notes, you could. So let's say that this is C, center is C, okay? So in this situation, if I was looking for this segment, CB, and I knew, let's say that we knew that this was 12. So we're kind of transferring some information from our last problem. These two parts are 12. And we need to find this. And the radius given to us from, I guess, the previous problem is, it says it's 13. So the radius is 13. And so R equals 13. And so we need to find from C to B. And that's not something that's really clearly laid out for us. So here's what we have to do. We know that I could draw a radius literally anywhere on the circle, right? Anywhere from the center to the outer edge creates a radius. So if I go all the way to the end, this is a radius. So here's the cool thing. If I know that these two segments create a 90-degree angle, and I draw my radius from the center to the end of my chord here, I will create a right triangle. And so if I know that the radius is 13, that means this segment here is 13. I know this segment is 12. I have a right triangle, which means I can fill in to find this third side using the Pythagorean theorem. Or if you know your triples, you can identify that this is actually one of your triples. So this is a leg. I'm looking for another leg, and I'm given the hypotenuse. So we're going to write 12 squared plus x squared as that leg that we don't know equals 13 squared. So 12 squared is 144 plus x squared. 13 squared is 169, I believe. Subtract 144, and x squared equals 25. 25 square rooted is 5. So CB equals 5. And I used a right triangle to help me find that. Who knew I would be using right triangles to help me find stuff with circles? But I did. So if you memorized your triples, you know this is a 5, 12, 13. Okay, let's go back to our study guide. So you can bring that information back to your study guide and say, okay, I'm gonna connect P to S and say, this is my radius, that's 13 from T to S is 12, because I know that RT is 12, so T to S is 12, and then I can work this out, and this would be 12 squared plus X squared equals 13 squared, and when you worked it out, X equals 5. And so actually this is PT equals 5. All right, let's talk about TQ now. So this time we need to find from T to Q. So we're going to use the same logic. From T to Q, actually we're going to use a little bit different logic because I know that TP right here is 5, and I know that from Q to T is a radius. So this entire thing is a radius. And don't I already know what my radius is? It's 13, right? So if this tiny segment is 5 and the entire radius is 13, how could I find the remaining part from Q to T? Well, I could just subtract 5 from 13. And so that would be 6, no, 8, right? It would be 8. QT would be 8, or TQ would be 8. All right. So same idea going on 4, 5, and 6. Let's take a look at what we have here. Diameter is 12. So this time we have this entire diameter, which means if the diameter is 12, what's the radius? Well, the radius is going to be half of that, which is 6. Okay. CD is 8. C to D is 8. So this entire thing is 8. So that means half of it would be 4. This would be 4. This would be 4. The radius would be 6. This radius would be 6. The measure of arc CD is 90 degrees. This whole arc here is 90 degrees. Now it says we need to find the measure of DE. Okay, well, I know that the arcs, if it's bisected by a right angle or a diameter and it's splitting my arc here from my chord, then I know that those two parts will be congruent. And so if the whole thing is 90, half of it would be 45. So DE is 45 degrees. Now it's asking us to find FD. So from F to D, well, I know that C to D is 8, so half of that is 4. AF, okay, now we need to find AF. So I'm gonna kind of clear this out a little bit so that we don't have so much stuff going on. And we're gonna label our work. So here's the deal. We know that FD is 4. We need to find this tiny segment here. I can use what I know about my radius and just draw it from the center and connect it to D. And I can use that to help me find this, this tiny part, because I know that this hypotenuse of this right triangle is 6, because that's a radius there. And so now I can do 4 squared plus x squared equals 6 squared. So 4 squared is 4 times 4 is 16. X squared, 6 squared is 36. Subtract 16 from both sides, and you have 20. And this is going to be a decimal, isn't it? So 20 square rooted is 4.47, rounded to the nearest hundredth. Now this makes sense why it's telling me to round, because all my other things are whole numbers, but this one is not. So round to nearest hundredth, 4.47. Okay, take a look at 7 and 8, pause it, see if you can figure these out, and we'll do them together, okay? So down here you have circle R, TS is 21, and UV is 3x. It's saying what's x? Well, oh, we didn't talk about this. Okay, so let's add a little bit more to our notes. Add a little bit more to our notes, because this is kind of a new concept that connects to the old concept, but here's my circle. Ooh, not an oval, circle. So if you have two chords that are congruent, so these two chords are congruent, and they meet at the center, and the chords going from the center to the chord creates a 90-degree angle, then something that's interesting is that these two parts are equidistant from the center. So the center is here. From the center to the chord, those parts are equidistant, which means they are congruent. So let me label some of this stuff, I guess, because I think that would help us out. So let's say that this is a circle L, and this is a chord F, G. Where they intersect, that's X. Where they intersect here, that's Y. And then this is chord J, H. Okay, so in the same circle, two chords are congruent if they are equidistant from the center. And so vice versa, if they're equidistant from the center, then the chords are congruent. If the chords are congruent, then they are equidistant from the center, okay? So LX would be congruent to LY. And if this is true, then FG is congruent to JH. And so I can flip these two around. If GH is congruent to JH, if FG is congruent to JH, then they are the same distance, equidistant from the center. If they are equidistant from the center, then the chords will be congruent. So keep this in your notes, and let's go back and do our last two problems. So our last two problems here, we have the same thing. These are equidistant, 6, 6. So that means I know that ST and UV have to be congruent. So they've given me TS is 21 and UV is 3X. So to find X, I know they're congruent, so I can just work my way backwards, and X equals 7. In the circle Q, it says CD and CB are congruent, and GQ, so this part is X plus 5, and EQ, so this part is 3X minus 6. So if the chords are congruent, they're equidistant from the center, and so X plus 5 is equal to 3X minus 6. And so I can work this out, minus X plus 6 plus 6, and this is 11, and this would be 2X, and so this would be like what, 5.5 equals X, and that's your answer. All right, that's all I have. So make sure you check your RenWeb to make sure to see what kind of bookwork you have. You might also, I think your homework might be to do a practice worksheet, so just double check on that. All right, have a good day.